Hey everybody, welcome to a Signal 65 Video Insights. I'm Ryan Schrout, president at Signal 65, joined as quite often we do with Russ Fellows, who's our VP of Labs here at Signal 65. Russ, good to see you again.
Hello, thanks, Ryan.
And we have a really cool topic we're gonna talk about today. Recently, Russ published a paper looking at the performance and validation of the MI355X AI accelerator from AMD. And joining us to kind of talk about it and some of the implications of that data and the performance and the market segments, we have Mario, who's a Senior Director of Business Development at AMD, and Zhen Yu, who is a Senior Director of Software Engineering, specifically for the AI and Instinct group for those product segments. So both of you, thanks for joining us to talk about this. I'm really interested to get your take on the results we saw.
Great. Thanks for having us.
Thank you for having us.
So I think the first question I want to get to really, Mario, is the kind of general implications of AMD's success and growth in this market segment, right? A lot of the global AI companies are, I think 7 out of 10 is what AMD has claimed, are using Instinct GPUs at scale. At a high level, what do you see as kind of the differentiator? What's kind of driving that push, that success for AMD right now?
Yeah, thanks for the question. I think we're at a real tipping point within the AI industry. Raw performance used to be the norm, but we're seeing that focus shift from performance to more of a perf per dollar, perf per watt type of metrics. And there's a lot of different aspects within, from a hardware perspective that impact those things. One of the key differentiating features that we've had for a few generations now is our memory. For example, the MI355X that we just launched delivers 288 gigabytes of HBM3E memory, which also has up to 8 terabytes per second of bandwidth. Right. And what that does is it provides users the ability to contain larger models with smaller number of GPUs. Also do for language models, have larger context, right, to do inference, as well as, for text to video and text to images, like higher resolution, to bring richer experiences at a much more cost effective point. And so, we see those trends continuing to where models want to get more intelligent, know more about the users, make sure, it's not, it's providing accurate information as well, longer video context, on the generation side, content generation side. And so, all of those together is pointing to, where we bring tremendous value to the market.
I really look at it, you said it's not just about raw performance anymore. It's really like a maturing of the market where we're getting from, theory to deployment. And that just means there's going to be a lot of different kind of configurations and needs and ways that AI will be utilized by different enterprises and cloud providers and end customers. And so we're seeing that breadth kind of expand the scale and scope and need for AI compute, and Instinct GPUs have found a really interesting spot into that market. Now, Russ, we published our paper on signal65.com. If anybody hasn't seen it yet, I highly recommend they go to the research section there at our website and look up the paper. I'm curious, what kind of results stood out to you when you were in the Santa Clara office before even the announcement officially of the 355X GPU? What stood out?
I'd say the first thing that stood out was the well-integrated ROCm library. So I know people, that there's somebody else I won't mention that has their own library that's well known, and it's often described as a moat. And I think that's perhaps in the past was true, but that scares a lot of people away. How easy is it going to be to use AMD CPUs? And the software is just as important as the hardware. So we've seen over the years that AMD released successive generations of the Instinct line with great hardware performance, but I'd say the software almost surprised me in just how mature it was and how well performed. There were no issues. Downloaded the latest version of VLLM, SGLang, everything's all integrated. It worked out of the box. There was no, oh, wait, let me try this again, or let me do this special tweak. It was, just stock images, everything just worked. So that was slightly surprising in a good way.
What about from a performance perspective? Any particular data points stand out?
Yeah, I mean, there's quite a few data points. We ran through, 4 or 5 different models with different batch sizes and a whole bunch of different parameters. And across the board, the AMD 355X was either on par. I think, 1 or 2 cases, it was slightly below the competitor. But in the vast majority of cases, it was outperformed, the leading GPU or the most widely shipped GPU currently, to put it that way. So, across the board, the results were on par or better. So, not just one test. We didn't just cherry pick results and find the one case where it outperformed. Right. In virtually everything we looked at, it outperformed.
One of the examples I think that we saw was there was an example of some of the larger models like Llama, I think it was 3.1 405B. We saw roughly 2x throughput measurement in that particular result. I'm curious, Xinyu, can you explain, that's a pretty maybe it's a really surprising result to some people. What is it architecturally that enables some of that differentiation on that particular workload maybe?
Yeah, one thing is the standout is our memory subsystem. We have 288 gigabyte of HBM3E per GPU, which eliminated the memory bottlenecks, especially for inference at scale. And in addition, we have ultra-efficient compute. We have FP4, FP8 quantization supported via our ATER library in ROCOM, as well as we have a lot of other high-performance kernels. And those are very super efficient implemented, and it gives us a very good performance. And the ability to run the entire models on a single GPU without using the tensor parallelism, it's a game changer for latency and efficiency.
Yeah, that was one of the points that we recognized as well, is that even running a really large model like that 405B model, you don't have to use tensor parallelism. So, I mean, what does that translate to for an enterprise or a neo cloud or anybody, right, who's trying to deploy those models at scale?
Yeah, so avoid tensor parallelism means lower latency and higher throughputs, and also very simplified scaling. There's no more need to do inter-GPU synchronization, which reduces the communication overhead. So the developer can do deployment on a single card inferencing, which cut a lot of complexity and improve the resilience.
It's interesting. Russ, I'm curious, any thoughts on that? What does that mean maybe for a potential enterprise user or any kind of real world workload? Does that just mean if you have a multi-GPU configuration, you're more easily able to create different instances that can address different workloads in real time?
Yeah, exactly. You could have different GPUs dedicated to different groups or, different inferencing sessions. That way you don't have to do the context switching, right? Taking that long context of the interactive sessions back and forth between different GPUs, you eliminate all that. And I think we'll see if any of the neoclouds start to exploit this, but you could really do a lot with that by segmenting and dedicating just say, a single virtual GPU to a client. In that way, it's completely isolated. So the isolation mechanisms and security, capabilities are definitely enhanced by being able to run the entire model on a single GPU. Interesting.
Mario, I want to come back and ask you a little bit about customer impact of some of these points too. In the testing we looked at, the MI355X was able to outperform the NVIDIA B200 in some of our testing on both LLM inferencing and fine-tuning. What does that mean for customers that it can do both?
Yeah, I mean, I touched on a little before, but going one more step into detail, right? With memory really is the new bottleneck, particularly for serving these solutions. And so, right, just having richer user experiences, things around like, right, longer context, applications that also require like RAG, summarization tools, right, of like taking, not just like single documents, but right, a ton of them, right, and summarizing very crisply and accurately. Being able to do that very cost efficiently, that's really where the memory plays its advantage. Now on the fine tuning side, right, we're also, leading in the performance there. As you can see, within the measured data, you'll see that our 8 GPU system beats our competition's results by, our publicly posted results by about 10% on like the Llama 70B models. And again, right, a lot of that has to do with good compute performance, but also the fact that we do have memory, the memory advantage, and we can go into things like larger batching to do it more efficiently.
I even kind of have viewing this as its ability to do both kind of simplifies maybe some decision-making processes about which platforms any particular customer might invest in, because you don't necessarily have to choose then between best performance per dollar on inference and the ability to do fine-tuning at a reasonable rate if the MI355X can actually accomplish both, right?
Okay.
Russ touched on this a little bit at the beginning too, but ROCm is a critically important topic and a piece of this puzzle. Right. To Zhenyu, I'm curious if you can briefly touch on, the evolution of ROCm, how it supports today's LLMs, what feedback you're hearing from developers. I know I see a ton of interaction and activity and improvements just watching social media around ROCm now. But what's your perspective there?
We have a strong collaboration with the open source community, and ROCm now supports all the major frameworks. For inference, we support VIM, SGLang, Onyx, and for training, we support PyTorch ecosystem. We also support JAX. So all deeply optimized for MI355. And we also invested in the FP4 inference acceleration, kernel tuning, and Docker-ready environment. So give our customer a out-of-box experience there. And developers really like and appreciate our open source model like the Apache 2.0 and MIT license. And there's no per GPU fees, and it's a fast way to enable the rapid innovation there.
Yeah, I know Russ touched on it and sees it as a big positive. We work with a couple of different software developers and benchmark developers in the AI community, and they talk about that being a strong advantage as well. Mario, I want to ask you a question on MI355X adoption, right? This is something I think a lot of people want to understand. Like, where are you seeing the earliest significant traction, right? Is it enterprise, cloud, hyperscale, something in between?
Yeah, I mean, honestly, it's kind of all of the above, right? We're seeing strong traction across like enterprise customers who are doing on-prem deployments. Very strong demand across AI startups that are cloud native. And then, I think a testament to, right, how adoption has been even from our past generations is that, these emerging neoclouds, right, also see the business potential on their side, right, to want to provide instances that are not just kind of, I'll call it industry norm, but something, right, that can really differentiate and make them shine as well, right, and give them better business economics. Reasons why, that's happening again is, we offer these application level benefits. Our software stack, as you mentioned, right, is very easy to use. But the other thing is, we're also offering, what's more of a industry standard hardware that people have been used to seeing for, I'd say a couple of generations now, across the industry, not just necessarily our solution. And what that means is, right, from the time like we launch product to when our customers have something that's production level, right, within their, data centers is very fast. And so that's another advantage point of these customers really appreciate the fact that there's a quick time to where they can get access to the latest and greatest technology.
Mario, you touched on this at the beginning. Maybe I'll ask Xinyu as well. The idea of an AI deployment and somebody implementing it, whether it be enterprise or vertical integration or something else, this idea of prioritizing raw performance per dollar, power efficiency as a part of a total TCO calculation. I know all of them are important, but how do you see customers kind of prioritizing that today? And does that influencing anything that you do on the software development side?
Yeah, of course. Yeah. So customer wants all the three factors here, but what I see the most important thing is the performance per dollar. So AMD today deliver better dollar per token results that, thanks to our superior memory architecture, our open software policy, and also lower cost of the acquisition and operation. So I see the economies of the ARR changing, and MI355X is the optimized for that shift.
Russ, I'm curious from your point of view, right? We deal with a lot of different customers, both say software side, hardware side. Do you see that kind of prioritization shifting a little bit more from just give me the absolute fastest compute possible to, hey, we need to be smart about this from a performance per dollar perspective?
I do. I think, the more reports I read of, people are interested in AI and trying to do deployments, but the TCO and the payback and the ROI are starting to matter now. Companies are starting to ask, okay, what do we get for that investment? So, yeah, I think the days of completely open, blatant checks are almost gone. Not quite. But yeah, economics definitely matter. But I think it's certainly important. But I would also say that the fact that there's no software issues really with ROCm, and it has as good a performance as the leading product out there, that's all positive. It's not just a performance play, or a cost efficiency play. It's the software and the hardware are good also. So it's all important. And there's not many weaknesses that I see here.
Great. I think I want to kind of come in and conclude on maybe one more forward-looking question. I always like to try to get in one forward-looking direction. I'm not going to ask you for your plans for MI400 or what we should expect there in any great detail. But if you want to tell us about it, feel free. But for both of our AMD guests, as you look ahead, how do you view from your own lens how AMD Instinct or the ROCm roadmap will support this kind of next wave in evolution of AI? That could be agentic AI, multimodal systems, mixture of experts. What do you see that landscape shifting over the rest of this year, 26, 27 maybe?
Yeah, we are keeping watching the trend. I think we are building the software to support the next generation memory demands. That's the first thing. And today's ecosystem, you will see a lot of language model and other model. They are working together. So we have to build the agentic tool orchestration to help our customer to build their end, user scenario. And one more thing is for multimodality. That's also another important trend. So we're building the multimodality pipeline to help our customers succeed at that domain.
Yeah, and I guess from my side, what I would add is number one, there's still a lot of innovation happening in this space, and the need for compute continues to grow, almost exponentially, and so to keep up with that, one of the things we are doing is we are on an annual roadmap cadence to release new products. So you can obviously expect, more compute, more memory, improved software, solutions, to really drive that. And, we're on a journey where we're also not doing it alone, right? To the point of, we have 7 out of the 10, top AI users in the world, running on Instinct. We are getting a lot of insight and feedback, into where the industry or, where people think the industry is going. And, we're making sure that we're taking those inputs to create, to drive our roadmap to where we can provide the best in class solutions.
I can tell you it's incredibly exciting. It's hard to imagine that the next 12 months could be as disruptive as the previous 12 months, but all indications are that that will be the case. I come home at least once a week and demo something to my wife and kids about, look what I found AI doing today and how impressive it is across productivity and creation and real workloads. It's super impressive. Obviously, hey, everybody who's watched, thank you so much. Go to signal65.com, go to our research section, look up our papered analysis on the new AMD Instinct MI355X accelerator. It's definitely worth a read to get a better understanding of the performance and capabilities of this platform. And so Russ, Mario, Zhenyu, thank you so much for joining me on this. I really appreciate the time today.
Thank you.
Yeah, thanks for having us. Really appreciate it.
Thank you.
And thank you, everybody, for watching. Find us at signal65.com, and we'll talk to you soon.